So in this video we're going to go over how to determine when a set of points is collinear. So we want to know if the set of points P, Q, and R are collinear points. And when we're working in three-dimensional space, if we have 3 points in three-dimensional space, say P, Q, and R, those 3 points might form a triangle in three-dimensional space. But the other thing that can happen is the 3 points might lie on a line. And when 3 points lie on the same line, we say that the points are collinear. So that's all collinearity is. Collinear points lie on the same line. So if I grab myself, pointer options, ink color, black, hopefully that got me the color black, and it didn't. Let's try this one more time. We go print, pointer options, ink color, black. So the idea is behind this is if they are on the same line, then any 2 vectors you construct using those points, like the vector P to Q, R to Q, they have to be parallel vectors. So PQ, PQ, R, if PQ and R are collinear, PQ and PR will be parallel vectors. So all we need to do to check for collinearity is to construct 2 vectors, making sure that we include all 3 points in the vector construction, and then we check to see whether we have parallel vectors or not. So for example, I could calculate the vector PQ, which is just the vector PQ is going to be 3 minus 1 in the x position, x component, negative 4 minus negative 3 in the y component, and 2 minus 1 in the z component, which is going to be the vector 2, negative 1, 1 when we simplify. And then I can calculate the vector P to R, which means I will have used all 3 points P, Q, and R in my vector calculations. So the vector from P to R is going to be the vector 7 minus 1, negative 6 in the y component, minus negative 3, and 4 minus 1, which is going to equal the vector 6, comma, negative 3, comma, 3. And as in the previous video, if these 2 vectors are parallel, then there's going to exist a scalar such that 6, negative 3, 3 is going to be equal to the scalar times the vector 2, negative 1, 1. So in other words, we need to find C such that 6 equals twice C, negative 3 equals the opposite of C, and 3 equals C times 1 is C. And as long as these 3 equations have the same solution, we know we have a parallel vector. So 6 equals 2 times C means 3 equals C. Multiply both sides by negative 1, 3 equals C, and here 3 already equals C. So that tells us that the vector 2, negative 1, 1 is a scalar, the vector 6, negative 3, 3 is a scalar multiple of the vector 2, negative 1, 1. Therefore, PQ and PR are parallel, and because they're parallel, because PQ, PR are parallel, we can deduce or conclude that PQR are collinear points.